Hello, this is Mr. Goma. I'd like to talk about and solve together question 4 on the worksheet on polarity. This is the question here. I've copied it onto a separate sheet of paper. It says arrange the following bonds in order of increasing polarity. Carbon-boron, sulfur-sulfur, sodium, fluorine, and hydrogen-chlorine. Well, if we want to talk about polar bonds, let's just remind ourselves about what polar means. Polar is something with opposite ends. And in chemistry, the opposite ends are going to be negatively and positively charged. In a polar bond, one end of the bond is going to be more positive and the other one is going to be more negative. Now remember, bonds don't have to be entirely positively and negatively charged. One end could be a partial positive and one end could be a partial negative charge. And when does this occur? This occurs when one of the atoms in the bond is more electronegative than the other. So that means we'll need to use our periodic table in order to figure out the relative difference in electronegativity between the two atoms in a bond. So looking at the periodic table, you'll remember that elements in the upper right of the periodic table, like fluorine, are very electronegative. And elements in the lower left of the periodic table are not very electronegative. So that means something like fluorine really wants to gain electrons, and something like francium has a very weak attraction for electrons. In fact, it'll probably lose electrons. And our trend is increasing as we go up and to the right. So electronegativity is the highest for the nonmetals, remember, separated from the metals by the staircase, and electronegativity is going to be lower for the metals. Okay, so let's go ahead and solve this problem here, which is arrange the following bonds in order of increasing polarity. So what I want to do is I want to look for the bonds that we know are going to be the least polar. So if I look here, first I see SS, so sulfur-sulfur. That means that two sulfur atoms are bonded together. This is going to be a very non-polar bond because there's going to be no difference in electronegativity. So we know SS is going to be the least polar. There's going to be no difference in, I'll do En for electronegativity. Okay, so now of the other bonds, we'll have to look at the periodic table in order to figure out the difference in electronegativity. So the other bonds that we have, I'll put this up here, are going to be Cb for carbon and boron, NaF, Na is over here and fluorine is over here, and HCl. So remember, elements that are close together on the periodic table are going to have a small electronegativity difference, while elements that are far apart are going to have a much larger electronegativity difference. The bigger the electronegativity difference, the more polar the bond. So obviously boron and carbon, are right next to each other, so they're going to have a small electronegativity difference. So this is going to be a pretty non-polar bond as well. So next we'll go carbon-boron, small difference in electronegativity. So that will be the next bond that we have there. So looking at the other two bonds, or the last two bonds really, we're going to be analyzing HCl versus NaF. So remember, electronegativity increases as we go to the upper right, so fluorine is going to be more electronegative than chlorine. And it decreases as we go down. So sodium is less electronegative than hydrogen. So therefore, sodium and fluorine are going to have a bigger electronegativity difference than hydrogen and chlorine. So over here for the largest difference in electronegativity, that will be the most polar, is going to be NaF. That's the most polar. And this is going to be actually an ionic bond because it's a metal and nonmetal. Metal plus nonmetal. Okay, and just to confirm, let's look back here for HCl. Remember, hydrogen and chlorine are both nonmetals. Hydrogen's a nonmetal. It's the one exception. It's on the left-hand side of the staircase. So they're pretty far apart. So this is definitely going to be a polar bond, but not quite as polar as the bond between sodium and fluorine. So HCl, there's going to be a big electronegativity difference, but both non-metals. So this is the order that you should have gotten from least polar to most polar.